everyone, and thanks for joining me today as we look to verify inverse functions. Now, two functions, let's just call them f of x and g of x, are going to be inverses if and only if f of g of x is equal to g of f of x, which is equal to x. And what that means is that you just have to show that the compositions are equal to x. So f of g and then g of f, when you simplify that they're equal to x. And that's what I'll show you today in the video. Something else that you can do is you can actually find the inverse of each function separately. So the inverse of f and the inverse of g, right? Remember that means switching the x and the y and then solving for the new y. And then you're going to show that those inverses, those answers are going to be equal to each other. So two ways to show and verify whether functions are inverses. Now here in example 1, we have two functions f and g. So what we're going to do is we're going to do a first composition of f of g of x. So I'm going to take my f function, and in that spot of x, I need to put in the g function, right? Work from the inside out. So inside function has to go within the outside function. So remember that I'm just going to be putting that expression in parentheses. When you have parentheses, you're going to notice that I should distribute to simplify. So when I distribute my -4 and then -1/4, that simplifies to 1x. Then I've got -8 and a +8. When I simplify those 8s, I get 1x, which will be good so far, right? We wanted our compositions to be equal to x. So first composition is good. Let's go to the second composition. So let's do the other way around. So g of f of x. So inside function is going to go into the g function, which is -1/4 x plus 2. So in x, I'm going to put in my f function, right? Put that expression in parentheses here. Distribute. And then simplify. So I'm going to also get 1x or x. So because both of the compositions are equal to x, these two functions are inverses of each other. Okay, so now let's look at example number 2. I've got two new sets of functions here for f and g. So my first composition, f of g of x. Here we go. I've got my f function, and in that x, I'm going to put in the g function, which is the inside function, putting that expression again in parentheses. Distribute to simplify, and that -2 actually simplifies to x minus 4. So because my composition needs to be equal to x, and it's not, I don't even have to do the second composition. I don't even have to do g of f. These are already not going to be inverses. Okay, in example number 3, here we go. New set of functions for f and g. So first composition. And in that place of x, I'm going to put in my g function, the cube root function. So notice how that goes all in place of where that x was, and that whole expression that's in parentheses now is going to be raised to the third power. So now how do I go ahead and simplify this? The cube root actually cancels out that cubed, that power. So I'm left with that expression that was underneath the radical. Now my 2 that's in the front, remember that's multiplied. So then I have a multiplied by 2, and then I also have the inside that's divided by 2. So those 2's will cancel. And now that +1 minus 1 is going to cancel each other out, and I'm going to be left with x. So now let's go ahead and find that other composition. So let's do g of f of x. So again, in that spot that has the x, I'm going to put in my inside function, which is the f of x. So rewriting that cube root, here we go. We got that expression 2x to the third minus 1, and then +1 over 2. Notice that right now, my -1 plus 1 are going to cancel each other out. So now I have a 2 over 2, so those could actually simplify and cancel each other out. And now here again, I have a cube root, and I have just an x that got cubed, so that will cancel each other out, and I'm left with x. Now, because I have an x and an x for both compositions here in example number 3, I am good. These functions are inverses of each other. Okay, so here are some things for you to remember. Now, if you want to verify whether or not these functions are inverses of each other using algebra, you've got 2 ways to do it. You can show that the compositions have to be equal to x, that they're both going to get you an x. Or like in the previous lesson that we did, you can actually find the inverse of each of those functions, and then those answers actually have to be equal to each other. Now, I hope you found this video helpful. You're good and you can find and verify inverse functions. Thanks for watching and have a great day.